I think we'll get started and let people come in. So today this talk, and I can go as long as you wish, but I really want to focus on design patterns. We have always heard about frameworks, right? And I used to be a Java architect for about 15 years or so and saw a lot of design patterns, right? And design patterns as such is a weak area, if you like to call it, in Node.js. And often we go about choosing a framework, based on peer recommendation, based on a particular feature we liked, a particular use case we liked, right? We don't really realize that behind all these frameworks, there are lots of them, right? If you go search for a Node.js framework, you'll probably find like 10, 12 choices out there, right? So what's some of the design patterns which are driving adoption of frameworks? And while you make your decision, what is the right platform to choose either way, right? So I'm not going to make a plug for any one framework. But that being said, we'll give you some decision matrix, right, to go about it. A little bit about me. I'm Shubhra. I'm essentially head of products and education at StrongLoop. Doesn't mean much, right? I just say things, developers hear, some of that gets coded, rest get thrown out. That's my Twitter handle. All right. So a little bit about, folks who use Express, show of hands. Okay. Obviously, you are in this room because you might be using Node.js Core. And who has heard about IO.js? Okay. So we work on all these three platforms. Those are our major platforms. That's kind of, if you look at the top there, that's half of the Node.js Core team. They work for StrongLoop. We also maintain Express, and instead of launching Express 6 or Express 7, we decided to package an ORM framework called Loopback on top of Express, right? So we'll talk about Loopback as we go through some of the frameworks. Additionally, we have about other 100 open source modules that we work actively and contribute to the community. So please feel free to check out, okay? Cool. So about today's talks, right, we say patterns. So nobody really creates a pattern. They evolve. Not said by someone famous, it's actually said by me right now here. But that being said, let's see the evolution of JavaScript patterns, particularly on the backend side, right? So we all have heard about traditional DIY, and we are very familiar with MVC, right? MVC has existed in Java, .NET, on the front end, right? All those frameworks have MVC. On the back end, when MVC evolved, particularly for Node, it evolved with unopinionated frameworks, right? And the focus was on middleware, okay? Connecting the dots, putting that into a model, somehow putting a controller layer, serving that up in a view, so on. So in this first of the block was what we call as Express, and that's why you see it has 16,000 GitHub stars, worldwide adoption. Everybody has some application running on Express, right? So here's a very simple example of writing a router, okay, or defining a routing in Express, okay. So if you look at the focus on middleware, it was built on top of Connect.js. And if you look at the core module, so whenever you say, okay, var express, require express, you are essentially, and say var app equals express, you are instantiating an express app. However, then you are calling a particular function, and that function happens to be express.router. And that is a traditional middleware function that comes baked in, along with other middleware functions like body parts and so on, right? Now, if you look at defining an API route, right? Let's start with at the ground floor. You're starting with basic CRUD operations. Then as you go building on top of it, then you can provide custom operations, and then you can set up routing. Now, if you really look at a function at that level, you can define and create a group of, say, item route.route / item ID, right? I'm my minimum unit of routing is a filtered item called as item ID, right? Based on that, I'll say, okay, create a put, a post, a delete, all these CRUD operations. And I'll actually have to deal with the request, process that request, manage the state, post the response, and then move on, right? So if I define a configuration like this, how does V8 go ahead and process this? It's essentially looking from the top to bottom and trying to find a matching pattern, right? If there's a matching pattern, it will process it, else move on, and that's where you see the next tick. It actually tries to process the next pattern, whether the incoming request matches one of these, URLs, and if it is a post, I do a processing and so on. So this is pretty much what you call it DIY or construction block framework, right? In came Restify, and it borrowed very, very heavily from Express, right? But one use case Restify typically tried to solve was just REST API creation, right? Express had the net cast a little bit wider. So if you are looking at things like templating, okay, Express probably had templating as a first-class citizen, right? That's where Jade, Handlebar, Mustache, all those come in. If you look at Express in terms of additional ecosystem framework support, like hey, I want to connect to MongoDB, out of box, Express is compatible with Mongoose. Go use that, right? I wanted to do authentication. I have passport.js as a plugin, almost as a plugin. Plug and play, 112 authentication types. Go use that, right? Restify did not really take that approach. Its use case was just REST APIs, right? And if you look at this, when you actually create a server and you say restify.create server, it's also taking that models approach, but this is eventually meant for that server has a function defined automatically to do the routing. You don't have to put a custom middleware for router. That's kind of inherent out of that pattern. However, instead of just filtering on a specific item or an item ID, you can now group your REST calls almost like in buckets, right? So maybe I created a REST bucket for items, right? Or maybe I created for products, and based on the product ID, then I can do some filtering, I can do find by operations, I can do custom queries, all based on that REST API namespace. But the rest of the implementation is pretty much the same, right? It's very hard to even differentiate much of the code from here from normal Express code, right? So let's look at a few pros and cons, right? It's highly unopinionated. Nobody's going to tell you how to do it. That's good. It's a great starting point. Nearly, no learning curve, right? And fully customizable. But if you look at Express, this was targeted as a browser or web middleware framework. Now, on the con side, which is essentially the same for Restify and Express, all those endpoints had to be hand-coded. Okay? When you tested those endpoints, they had to be hand-tested manually. If you refactored your code, you have to rebuild those endpoints and retest all over again. There was no out-of-box automatic CRUD operation creator in either of these DIY frameworks. Okay. Now, if you look at some of the pros of Restify, particularly if you're running this on Solaris, right? There are certain features, functions like dtrace, right? It has automatic dtrace support. If you're running this with a web server, which supports SPDY protocol, right? It has built-in SPDY support. So that's really good, right? It has strict API, but and again, this is a very stable and highly actively developed. But again, it has strict API with HTTP interactions, right? That's pretty much it. But like when you talk about things like tracing and all, you can get additional visibility around latency, particularly on the network versus machine layer or the I/O operations with a framework like Restify, but not again on every platform, right? Your platform that you're running has to support dtrace. So forget doing this on Windows, right? So you have a few options there. So that was pattern number one, right? And along came a configuration-driven pattern. So a step further from just DIY, and you can say, okay, I can specify a configuration module, and this is where Hapi evolved, right? It came out of Walmart Labs and all. You can in a way say that Restify and Express are also configuration driven, but there's too much unopinionation around that world to make it configuration driven. That's why I call it a DIY. So let's take a same look at the same routing example using Hapi, right? So Hapi was traditionally modeled to control web server operations. Okay, and that's what it's really good at. So if you say, hey, go and create a server on this specific IP and on this specific port, and I have exposed configuration functions, one of them happens to be something called as pre-handler, right? So before a request comes in and I handle it off, intercept the request and do some pre-processing on those requests, okay? And when and if you look down the code here which says server.route, what I'm doing is I'm invoking an handler function. But on this handler function, I can pass it a set of configuration. So I'm saying that config this handler function, and this handler function will deal with all requests and reply. And for methods, like, okay, this is a post method, again configure that same handler function to do XYZ. And similarly, if I get something called as a post function, again configure the handler function, right? So handler almost acts like a pseudo middleware, right? So you have these set of config functions that you are exposing, and the logic of routing is within that handler function, right? So this is good, but particularly if you look at pros and cons, right? That's not just what Hapi does. Hapi does a lot of other things. I really like it. So it's supported by Walmart Labs. That's good. You have extreme granularity over HTTP request streams, right? And how do you respond it? The documentation and the API spec is very detailed. That's good. If you are really looking at things like a plugin-based architecture, right? Which, yeah, Express has it. You can pull down Express modules and so on. But if you're really looking at building something a little bit more enterprise grade, right? Hapi has these plugins. Some of them are like Catbox, Joy, TV, Boom. They address certain functions like, hey, I wanted to do authentication, right? I can go and just use a plugin module for doing that, okay? I wanted to just do geopoint location. I can go and, plug in Travelog, right? That's all good. What else? Obviously, I would say, if your primary interest is to control what kind of content gets rendered on what type of web servers, and if you want to handle the request in 10 different types of ways, maybe I want to keep certain sessions sticky to a certain set of web servers, have static processing on a certain set of web servers, do the dynamic rendering on another set of web servers. All those levels of controls are very good in Hapi, right? And Walmart has built this framework. Not that Hapi is the only one among them. If you talk to the PayPal guys, they'll advocate 3 or 4 frameworks of their own, right? Kraken being one of them, okay? So let's look at the third pattern. This pattern is called as ORM. Who is familiar with ORM, just from a traditional one? Okay, a few of them. So this is not something that was invented in JavaScript, right? ORM has existed for a long, long time. You saw Hibernate. You saw, maybe in a way Spring Struts adopting that in the Java world. As you went on to even the Node.js world, right? Or rather MongoDB world, there was a data-driven ORM. In this case, it was called ODM that evolved out of MongoDB, right? However, it only worked for MongoDB. And unless your data source is only MongoDB, it won't really work for everything, right? But it's a good start. So the focus here is on model-driven development. And we'll talk about what that means. And here, the stress is on being able to connect and conduct ORM with any data source, be it a relational data source, be it a object JSON-driven data source like a MongoDB, be it consuming REST APIs or SOAP APIs and so on, okay? And the third key item here is automatic REST API endpoint generation, so that you don't really have to go down to the Express level and hand code each of your CRUD operations. Is there a way that I can create a model in JavaScript, abstract the logic, like let's say there's a database table, and when I was making an API call, I was dealing with that table directly through a stored procedure or whatever. But if I want to break that dependency from the backend, abstract a database table or a REST operation or a WSDL from SOAP, and model it as JSON objects, or rather JavaScript objects, and do all the API generation based on those JavaScript objects using variety of specs, right? Swagger is one of the key components which is helping you do that. Has anybody heard about the Swagger project? A few. You should look it up. I think it's going to be the industry's benchmark in terms of API spec. And it was a consortium. StrongLoop was one of the contributors. Hapi came in and contributed to that spec as well. And as long as you can detail out the documentation spec, you can essentially reverse engineer code from that. Okay, cool. So let's look at a framework, Loopback. We built this on top of Express. So you can call it Express Enterprise, Express on steroids, whatever. But that being said, the same router example, we said, let's plug routing, basic routing, as a middleware function where you don't even need to bother with that. Let's bring in some level of automation, right? And if you look at all the CRUD endpoints, they should get created automatically, updated automatically. As you just update your backend models, all the API endpoints should also get updated automatically, okay? And this is the Swagger interface. You know, this is the Swagger project. You can even go and import this. It's a great tool for visualization, documenting your API, as well as reverse generation of code from your API spec itself, right? So I'll make a big plug for it. I think this is going to change the API space altogether, right? So if you have to use this with something like Loopback, we made it a first-class citizen, and we just said, Loopback Explorer, just use this custom Explorer, which is essentially the Swagger client and the Swagger tool. As long as you are creating models from the backend, plugging it with Swagger, all the APIs are auto-generated for you. Okay. Now, another framework which takes this ORM approach is Sails.js. Okay, pretty mature. I think it's probably one of the most popular ones after Express. Although Loopback is probably the fastest growing one, but Sails has been there for a while now. Now, if you look at the same routing example, I think Sails also does it in terms of that you don't really have to define the middleware. You just have to define your patterns, right? Your namespace matching. So you say, hey, get sign up, and then you basically define what view it should go to, and the controller takes care of all the routing built in, right? So I'm not going to go too detailed into this. You can look up the Sails documentation. So what are the strengths and weaknesses of a traditional ORM-based framework, right? So number one advantage, you can stand up RESTful APIs literally in minutes or hours, right? Without having to dabble in a project for days and weeks. It advocates convention over configuration, so it's opinionated, right? In a way, that's good. There are built-in models ready to use, and if we have time after this talk, if you want me to run some live code examples, I'll show you how easy it's to generate models and then publish APIs around that. Some of these also took what we call as RPC support, and in the next one that I compare, I'll talk a little bit more detail into RPC or remoting, because I think we had an excellent talk from Meteor, and I think Meteor also leverages what we call as isomorphism in a way, right? So we'll talk about that. The whole premise here is to have as many data connectors or as many services connectors, right, when you build a ORM framework. And there are other key things here, that when you are building an ORM, you are not essentially trying to just address a web channel. You want it to work for omni-channel or multi-channel, right? So if you think about Loopback, we built in a bunch of mobile services, push notification, geolocation, offline sync, and as well as authentication, authorization, and validation. So what's the con, right? What's really the hard part about doing this? There's a learning curve. And the second is, because it's opinionated, you can configure. If it's built on top of Express, you can plug and play Express modules, right? And both Sails as well as Loopback are built on top of Express, right? So that's why I'm advocating those. But again, there's a little bit of opinionated frameworks, which helps productivity in a way, but you may not like it, okay? All right, so let's look at the fourth design pattern, which we call as isomorphic JavaScript, or rather what we are now talking about in terms of full stack JavaScript development, right? So folks used to joke in the earlier days about a JavaScript database, right? So I said, okay, on the front end, I have JavaScript and I'm doing Angular, for example. On the middleware, now you have JavaScript, which can process JSON, right? Essentially happens to be Node. And on the front end, I am consuming JSON. But what happens on the back end, right? Is there some way to persist JSON? And can you name me a JSON DB? Anyone here? Couch? Mongo, right? So it basically, as soon as Mongo hit, and then people realized, hey, now can actually have a full stack JavaScript solution, right? So that's one. However, the focus here, the design pattern here is to share the server-side models that you are creating with the client side. How do you do that? You can do that essentially using packages like Browserify, where the Node.js models that you are creating on the server side, you can create a browser bundle and run it within the browser. Or you can use a remoting protocol. In the Java days, when Java was evolving, folks had realized the need for building a bridging layer called as JAX-RS, right? So we actually wrote a protocol. It's called Strong Remoting, essentially helping you do the same in Node.js. Okay, it's totally open source. Try it out. The second theme here was when you're designing for omni-channel, you're not just designing for a mobile web framework, right? And this also, like along on the front end, what started happening, people were doing native development, right? But slowly the trend started shifting towards hybrid development as Cordova and PhoneGap came in. So you now have full JavaScript on the front end, and if you're writing a hybrid app, you're as close to native. I won't say like 100% close. It's as close to native in terms of performance as well as user experience, right? But you can still use those APIs and share the models from the back end as is. Okay. If you're really interested, this is a very interesting use case. I may be able to run an example here. We'll see. So let's talk about Loopback, and then I'll go into, I think you have heard about Meteor, but I'll just touch about this. So when we talked about Loopback, what we said was we created a bunch of connectors, and then the community guys came in and they wrote a lot of connectors, like a CouchDB connector, or an Apache Kafka connector, or an SAP HANA connector. All these came out of the community. Originally, when we started, we said, okay, let's write a relational set of connectors, Oracle, SQL Server, Postgres, so on. And then we said, okay, let's do the second set of connectors, which would be services connectors. So you want to consume SOAP, right? And you want to break it down into JSON. So let's write a SOAP connector. You want to consume existing REST, write a REST connector, right? Or maybe the third category of connectors were what we call as non-structured connectors. Hey, I want to connect this and consume a JSON object, a collection object from MongoDB. As long as that is represented as JSON on the backend, there is nothing stopping me from converting that into a JSON representation on the middleware in Node.js, essentially modeling out of that collection as a single object. Okay, and as you went ahead, right, now you're seeing the emergence of Apache Kafka, which is very much plays into the Hadoop big data space from connectors. If you have you guys heard about the Node-RED project from IBM? You should check it out. That's meant for IoT. Has a lot of MQTT as well as IoT connector space, and they have agreed to collaborate with Loopback as the open source framework, and even IoTT's Node-RED is fully open source, and they're going to develop a lot of the streaming as well as the IoT connector support within this infrastructure. Okay, so how does this work? Everything, whether it's a database table, it's a SOAP operation defined by a WSDL, it could be a REST call. Everything is gathered as an object, or rather a JavaScript model. On those models, now you can do ORM. You can do relationship mapping. You can add access rules. You can do aggregation, customization. And because it's the middleware that we use to render the API happens to be Swagger, it will automatically convert those into a JSON API for you with all the documentation as the test simulation built in. Okay? And on the front end, what happens is we have all these channel SDKs, right? So you can drop in an SDK, in an Angular SDK, a native SDK. But what's unique about this is between the client side here and the server side here, these models that you just created or auto-discovered from the backend are shared in their state and their spec. So what happens, it's also called as two-way replication. If you look at CouchDB, We essentially borrowed some of the concepts from that, right? But what we did was we implemented an object DB storage in the HTML local 5 browser, right? And so all the time, the models get synced over the wire. Now, if you get offline due to any chance, what happens to the model on the front end, maybe in an Angular app, that model gets persisted in your local HTML5 browser storage. As we come online, the model gets synced over the wire, and there is always an event polling going on to watch for the state of the model on the client side and the server side. And if you, obviously you will have conflict because the models could have changed on the client side, or maybe the models could have changed on the server side while you were not connected, you were offline. At that state, you can actually do conflict management on the middleware itself, on the server side, okay? So we'll talk about this a little bit more, contact me, I can give you a running GitHub project also. So let's look at the, the Meteor one. And if I'm misrepresenting, by no chance I'm a Meteor expert, but from a pattern perspective, I think I recognize this as, I would say, a full stack isomorphic pattern, right? You have similar client server based modeling, and on the server side, this is like somebody's architecture, right? This is not Meteor architecture. Somebody created an architecture using Meteor, okay? So essentially they were connecting with MongoDB, right? And on the MongoDB one, there were some methods exposed. And on the client side, you are essentially running that within a Browserify package. You're running that within the browser. And if you're looking at mini Mongo, that's essentially a stub call to the client side model on the server side, right? And obviously, if you're dealing with the connections and the transport, I don't know what you guys really use under the hood for isomorphism. We use the remoting protocol. Have you guys actually written a protocol around that, or are you using like more Browserify type sharing?
I don't actually work for Meteor.
I don't? Oh, okay. Okay. All right.
I can explain it, but you should just...
Okay. Got it. So anyway, look at, I don't know what the real wiring is under the hood, but it's essentially the same concept, right? Sharing server-side models with the client-side models. Getting to a stack which is isomorphically JavaScript. You don't have to transform, retransform, serialize. Helps your latency use case, reduce the latency. Your APIs are really lightweight, right? So pattern 5, microservices. Was there a microservices talk before this? Oh. Okay, Tony did that. Okay, so to start with, there is no fixed microservices pattern. Everybody has their own definition of what a microservice is. I'm going to present what I am seeing from a lot of our customers and the people I've been discussing this on the community. Some of that might resonate, right? So the design concept here is called decomposition, and I'll talk about that. The second focus is containment. So when you talk about containment, I need to run this microservice within its own container, managing the entire runtime, managing the entire life cycle, the up-down state, as well as managing the entire connection, as well as the remoting from that microservice out to any client app, right? Regardless of other microservices which are bundled in this API ecosystem or my API application that I have running on the back end. The third concept here is flexibility, and the fourth is hyperscale. Why am I going microservices? Why not build a fat API app and just expose this? One thing I want to achieve is hyperscaling. So let's talk about it from a design pattern perspective. So this was the classic pattern called as recomposition, right? I have a RESTful service coming from the cloud. I have somewhere an SOA stack. I have database, I have an existing ESB, or maybe certain XML. I want to convert everything into JSON. But that being said, let's not change anything here on the back end. Let's put what we call as a gateway, right? Let's consume these using existing connectors, existing service connectors. I'm not going to go directly against the data source. I'm just going to work off the services layer, right? And then try to put authentication, routing, mediation, right? Rate limiting, some kind of orchestration. Even I can say, okay, this is one REST call, this is another REST call. Instead of serving up a SOAP, maybe I can orchestrate these two REST calls and serve up a hybrid aggregated API, right? So all that was done without touching the core stack. Good approach, helps you get the foot in the door, right? Because you don't want to disrupt your 10-year-old SOA stack. And you'll get kicked out. However, this does not solve the fundamental problem. The fundamental problem is if I just aggregate existing APIs, if I just serve them up through a channel, and maybe I expose some SDKs to a developer portal, and my end developers can code against that, it's not making my APIs any faster, right? And in the mobile land, as well as the IoT land, my latency demand on my API has increased tenfold. If I was serving a page at 1 second, I now need to serve that REST API call at 100 milliseconds. Even that is not good enough for an IoT use case. I need to serve that up as a 10 millisecond latency. How do I do that, right? Obviously, the speed of light, all that kind of discounted, right? What's the core processing time of that API? So a new pattern has emerged. I call this pattern as decomposition. Break your core API layer. I'm going to make a bold statement here. Okay, but there are serious architects who have managed to implement this pattern. What they said is, I have that soap, I have that table, but instead of serving you a soap, I'm going to decompose that soap. And that soap is, I have a WSDL spec around that soap message. I'm going to take every method out of that soap call and decompose it into JSON. Now, obviously, my SOA layer was doing the orchestration and mediation for me, but then I was bound by the response times and the Java runtime, or maybe the .NET runtime, which was serving that orchestration logic. I'm going to just do it super simple in JavaScript at the speed and the scale that Node.js gives me. Okay? So I'm essentially breaking this, fragmenting these APIs down into tinier API microservices. Okay? Now, as your app server was rendering HTML, now you have an API server rendering small, lightweight JSON APIs, right? So how does this look a little bit more architecturally? Okay, what this means is, hey, I consumed, maybe there was a standalone service, backend service. I consumed a micro API. That micro API is a representation of a data model backed by some connector. It could be a data connector, a services connector, whatever. And the dependencies of that model to other models. Okay? And that model itself is exposed through some kind of remoting to my client side on the gateway or on the client interface to it. And this itself becomes what we call as an integration platform as a service. So each of these microservice has to run standalone within its own container. And so obviously it needs some kind of orchestrator, right? An API orchestrator. Because when the call comes in from the front end, you get a REST request or a JSON request, right? Now who does the routing? If you were able to provision these tiny microservices in containers, and if you were able to maintain the state information in some kind of a store, the entire routing logic which you had been till now writing in Express.js, or that's why I showed you the routing examples, right? All of that you had been doing in your code itself. Why not move that routing logic to one layer above what we know as a gateway? Okay, and but again, when the gateway, which is at the very top, that has an inbuilt router, that router has to be intelligent enough to be aware of where these microservices have been deployed. So at runtime, it can take the decision that, okay, this is a call coming in. It says /cars/v1, that's version 1. The second call coming in is /cars/inventory/v2. Right? So your differentiation in terms of the request could be based on version numbers, it could be based on HTTP parameters, it could be based on namespaces. So the router has to parse these, and based on some kind of a mapping rule, it has to route intelligently to where that individual RESTful microservice is running. Because this microservice right here could be V1 of your application, this could be V2 of your application. So if you're doing something like an A/B testing of your microservice, you could be taking routing decisions based on where the client is coming in for, or maybe it's based on your URL parameters. Make sense? So now, how do we deliver this, right? So this is what you do at design time. Now when you deliver this from a runtime perspective, I'm saying that I built out that designed that microservice, but can I run it within its own container, right? So you might have seen an evolution of another platform to deliver these runtime microservices called as Docker. Any Docker users here? Okay, so think about this service container as being a Docker image, okay? And I throw a set of bare metal servers, or not even bare metal, let's say some operating system, has to be Linux, right? Docker doesn't really work outside of Linux. And I have a farm, right? I say there are 10 servers, go deploy these microservices, where design time I compose that all in one app. But when you are deploying this, I want you to deploy a portion of this API, a portion of the second API, version 1, version 3, in different runtime containers, okay? So let's take an example. Version 1 of a car lookup service is deployed to container 1 here, and maybe container 2 and 3 on the second box, right? So how do you define the deployment? If there were a place where you can say that I need this microservice to be running on 3 Docker containers from a scalability perspective, choose those Docker containers from a pool of Docker containers available on your server farm and go and push and deploy that, right? However, Node.js being single-threaded and the runtime being not super steady, you have frequent crashes, right? You have frequent restarts of your application. Sometimes you will run out of resources, in which case you might need to again redeploy or provision another service container. So your service container configuration itself can be changing. Now, when you deploy this microservice to a service container, you want to ensure that it scales. So if you're using modules like cluster management or cluster control, you can spin up multiple processes and put a load balancer on top. Now, if you're using traditional cluster management, the load balancing is not really that great. We are seeing a pattern of adoption of Nginx as the load balancing for those processes. And obviously, you need things like monitoring and control time as well with high availability. Now, if these service containers can be orchestrated around that pool, what happens to the runtime state? All that runtime state now gets stored into a shared server, a caching server, which is updated every 30 seconds or so with the state of the microservice. And your API gateway, which is essentially doing the routing or rather proxying at that time, can look up the state from that shared store and make runtime routing decisions, right? So I think it's a lot to absorb. My head almost spins sometimes like this. But that being said, if you guys have any more questions, feel free to approach me, and I can help answer a little bit more around what we are doing with microservices. Anybody actually doing a real microservices deploy at this time? Okay, are you guys choosing like a Docker type of environment, or what's your approach here?
Cloud Foundry.
On Cloud Foundry itself. Yeah, and you'll see, this entire runtime, right? It's almost borrows from OpenStack. It's not really, a new wine, right, in Nodebot, but essentially we said, okay, you're doing this at the infrastructure level. Can you not just do it at the Node.js runtime level, right? You essentially is borrowing the best practices from both ends. So net, I would say that, you should not be really looking at frameworks, rather be looking at design patterns. And there could be use cases where, maybe a couple of frameworks make sense, right? Pick the best of each, right? Or maybe you want something super opinionated to make your life easier. Then you can look at, which is perfectly suits your use case, right? So that's about it. Thank you.